So today we will try to discuss only on standalone solar PV system types or classifications. Okay, so this is a part of our DC load. Okay, so let's try to understand what is meant by a standalone solar PV system. Okay, standalone means if anything is self-sufficient, if anything is self-sufficient of its own design, then it is called a standalone solar PV system. Here we have four types of solar PV systems. These four systems are inherently self-sufficient of their own, and they can happily run their DC load, and they can run with the DC loads and with AC load and DC loads. Okay, this is why these systems are called standalone solar PV system. On this will never turn off 24/7. They can have the power in such a way they are dynamically designed. Okay, so that's why the standalone systems are 100% perfect than compared to grid connected systems. Let's try to see what is this standalone. So actually, if you come as per the classification, we have standalone solar PV system, and next one grid connected solar PV system. But grid connected is one category. These are, otherwise we can call this standalone system as a off grid type. Off grid solar PV system. Off grid means, what is the meaning here? There's no grid here. We only will try to generate from the solar panel, and will use the electronic charge controller, and will try to energize the load. It may be an AC load or an DC load. That's why we can say that these systems are also called off grid system, where there is no grid is available. Let's try to discuss about the types. So standalone solar PV system are basically of four types. First one is solar PV system only with DC load. Okay, so solar PV system is directly connected to an DC load, but it has some few disadvantages. That disadvantages are overcome by adding an electronic control circuit. We'll discuss in detail. So that is the second classification, solar PV system with same DC load, and the next component what you are going to add is the electronic control circuit. So the drawback in this design is overcome by third one. So this consists of a solar PV system with a DC load, electronic control circuit, and a battery which can run the load for 24/7, which can run the load for 24 hours. So that's why we added an battery. So this is how the superior design. And the one more problem in this design is this can be operated only for DC load, but we need to also operate with AC load also. We require some AC loads also there in our domestic application. Therefore, this fourth design is there. So in all these four types, which is the best one if you ask? So the best off-grid solar PV system is solar PV system which can operate with AC load, DC load, which consists of electronic control charge controller, electronic control unit, and battery. So it is 100% suitable. We'll try to perform an experiment on this today. Okay. So coming to the detailed classification, so this like very simple solar PV system with an DC load. Okay, but this already outdated. I cannot say this is a good design. It's like outdated design and a bad design. So what is the design is? So we'll take one solar panel. So these solar panels may be an one solar panel, or maybe an two solar panel, may be connected in series or may be connected in parallel. If voltage is important, they will be connected in series. If current is important, they will be connected in parallel. So we'll be having a solar modules or solar array. This solar array is directly connected to the DC load, where the DC load I am going to take as a DC fan or an DC bulb. The problem here is when you have a DC bulb like this. So if solar radiation is varying, so how to write down the solar radiation is nothing but measured in watt per meter square. By using a solar meter or lux meter, we can measure the solar radiation. The solar radiation will be changing hour to hour. As the solar radiation is changing due to hour to hour, as well as due to this shadow effects, automatically the bulb will try to glow with low intensity or sometimes with high intensity. For example, if you have at 1 o'clock, the bulb will glow with high intensity. At morning, it will try to glow with low intensity. There's a main problem with this system. Why? Because the variations in the solar panel will be directly shown on the load. That's what the main drawback of this system. For example, if you have a fan, so fan will be running with minimum, if the input is very less. Morning, for example, morning you got only some 100 watt per meter square, early morning 6 o'clock. The fan will run with only with 100 rpm, where the fan speed is not sufficient to cool our body. Okay, then for example at afternoon or at 10 o'clock, the irradiation may be around 350. So irradiation is increased, automatic what will increase? The fan speed may be increased to around 250 rpm. Then you may be satisfied. But 1 o'clock what happens is it may reaches the maximum, which is nothing but 1000 watt per meter square, and fan speed also will go to up to 1500 to 1600 rpm, which is beyond the speed. The fan will try to rotate with the maximum speed, where this much speed is not desirable for us, where you can have discomfortness. And evening then the same will happen. Actually again the fan speed will decrease. Why? Because the solar radiation is going to decrease. Is it an happy load? I mean, can you say that the output customer having a DC fan, a DC bulb will be happy? The bulb is continuously flickering and the fan is continuously changing its speed. Is it desirable output? No. That's why I cannot say that this is a proper design. This is an improper design. That's why to overcome this design, we are going to add one more circuit, which is called electronic control unit or electronic control circuit or electronic control unit. Sir, why we are going to add this electronic control unit? It's very simple. So here the load is not satisfied. We need to perform a smooth operation of the load. So load should run with constant speed and bulb should give constant illumination or fixed illumination. I want a satisfied output. So for this, in order to make the load to run smoothly, I am going to connect an intermediate component which is called electronic control unit. This take care about all the voltage variations. So it will protect the battery from, for example, the next design we will study here. The electronic control circuit, we are going to add an battery. Sir, what this electronic control circuit is made up of, or what type of functions it is going to make? So it is going to make two functions. The first electronic component is called as the two functions are done by this electronic component. One is called as charge controller, also already we discussed with you, and it is also going to perform the next function with the help of a hardware called maximum power point tracking hardware. Sir, what this charge controller is going to do? So this charge controller is going to take care about protect the battery from overcharging. So battery is 100% full, still the solar system will try to charge the battery. Automatic the life of the battery is going to damage. So it protects the battery from overcharging. Already battery is discharged to 10%, still the battery is trying to drain or discharge. Automatically the life of the battery is going to damage. It protects the battery from over damage. It protects indirectly, I can say it protects the battery from voltage over discharge or the voltage fall. That is how this electronic charge controller is going to stabilize the voltage and try to maintain the voltage as per the requirement of the load, as the DC load may be available as 12 volt system, or it may be available as a 24 volt system. It may be in terms of 12 ones are 12, 12 twos are 24. If the further rating, how much voltage? 36. Further rating 40 volts. It depends upon the load we have at our house. But generally we don't have any DC load in your house. Why? Because DC load is very costly. Everyone will have only AC load. Okay. So to handle this voltage variation, we injected an intermediate component which is called electronic control circuit. Take care about all the voltage variation in such a way that the output load is smoothened. So you can say that the output is have a smoothened operation of the load, and this next is performed by an maximum power point tracker. So I told we had already studied this IV curve. So in this IV curve, if you see here, so this is a I curve, V curve. If you plot the IV curve of a solar panel, then you'll get a curve like this. At only one point, the maximum power is available in a solar panel. The corresponding maximum power, if you draw a line, this point is called maximum current and this point is called maximum voltage. The product of maximum voltage into maximum current is called maximum power. So we need to adjust, we have to take all the voltages from the solar panel and all the currents from the solar panel, and we have to see that the electronic charge controller will deliver the maximum power. Then automatically I can say that the 100% solar radiation is utilized. So this has to be done by a hardware. That hardware is called as a maximum power point tracker hardware. So if you don't have the hardware, for example, you can do with what is that, software and as well as the hardware. So this like a code will be dumped, and this code will take care how to generate the maximum or how to extract the maximum power from the solar panel, or you can use the tilt question, is already discussed. So this is also a type of maximum solar point extractor. So if the variation of solar radius, I mean if the variation of solar position, the solar panel also will change its direction, and all the time solar panel will be facing the sun such a way that the maximum power is extracted, or the maximum power is extracted from the sun. But this is too costly. We have to use a log mechanism, or we have to use a tilt switches, more build DC motors, more technology is required to make the solar panels to rotate, and the life of this design is also very less. So that's why what we'll do is we'll fix the solar panel facing which direction? South direction, and we'll try to use some hardware. That hardware is built with some hardware and software which can extract the maximum power from the available voltage and current. That is taken care by one component. In generally we'll call it as a electronic control circuit. That's why in intermediate we injected an electronic control circuit. What is the purpose of electronic control circuit? It take care about the smooth operation of the load, and it take care about how to utilize the maximum power from the solar panel. So this is all about SPV with DC load and electronic control circuit. Now what is the drawback? You understood? We understood this have some voltage issues, and we came to this design. In this design, it can be successful, it can operate the load only next time, morning time. If you want to run the load at night time, what I require? I require an extra help which is called as an battery, where this battery is called, which can be operated by 24/7. And the next problem here is we have DC load, we have electronic control unit, and we have an battery. And one more problem is we want to buy the DC load, which is very costly. So we need to convert this DC supply into AC supply with one more component which is called as inverter. The next class will discuss about SPV system with AC load and DC load with electronic charge control and battery. So with this the four classifications are very clear. So I can say that this is not an good configuration. Why? Because the output voltage is continuously varying. This is also not an proper configuration. Why? Because this can generate the power only in, I mean this can have the power only in morning time. If you want to run this DC load at night time, we cannot run it. So the examples of this DC, I mean standalone solar PV system is a DC bulb or solar street light system. Okay, here. So battery, electronic control unit, DC bulb. This is nothing but this is a very good design. We call it as solar street lighting. We have an experiment to do that. So street lighting, if you turn on, what will happen? Morning solar power is there. All the power will be stored in the battery in the morning time. At night time, the battery will try to discharge and will supply the power to the DC lamp. We can use this configuration in hilly areas where we don't have the electrification. So this is a good design. The best example is solar street lighting system. So we'll discuss about 3 and 4.